Welcome to Section 4, Reading Input, Calculation, and Handling Errors. In this video, we'll look at understanding assignment and operators. In this section, we are going to use Pig Latin as an example program. For most of you, I'm sure you have played Pig Latin before when you were young. For those that you have not, it's a very old English word game, and it's popular among children to learn it and confuse their friends. It's quite fun. Like any games, there's many variations. We're gonna just choose one and go with it. The main goal is to learn programming here. So for any words that starts with a vowel, we will add way to it. So example would be eat will become eat way. I will become I way. For any consonant starting words, we're gonna move the consonants, either one or the group of them, to the back and add AY. An example would be truck will become up tray. When dealing with consonant starting words, the letter Y behaves like a vowel. That's a special rule, so that more fun in our programming. Let's go. Okay, again, before jumping into the program, let's pick up a little bit on the theory side so that we have the tools. The first topic that we'll look at is assignment operator. We have actually used this quite a bit in the previous examples, just that we haven't really looked deeper into it. Let's go. It is definitely the most common operator in Java. All it is the equal sign, so we see that everywhere. What it does is it assigns values on the right to the operand on its left. When the value is of primitive type, it will be a copy. When a value is an object, it will be a reference. What that means, if we have int x equals 10 and int y equals x, and then we do x equals 4, at this point, y would actually still be holding on to 10 because it's a copy. Whereas if it's a reference, it will be a different story. Arithmetic operators. This one, I hope everyone should be quite familiar with it. There's the typical addition operator, subtraction operator, or plus minus, and multiplication operator, as well as division operator for your multiply and divide. Less frequently used one would be the percentage sign. We use that for modulus, or the remainder operator. You use that to get the remainder after you divide, which can be quite handy. Equality and relational operators. This one is quite straightforward. We have your equal to and not equal to, then the greater than and greater than or equal to, and similarly the less than and less than or equal to. They sound boring, but they are very useful, especially when you deal with primitives. Type comparison operator. This is more specific for Java. It helps us check whether an object is of a specified type. We can use it to check if B is instance of complex number to see if it's of that type. And it also abides by the rules of inheritance. So if we have a class hierarchy like animal, mammal, dog, terrier, Boston Terrier, and we have Sparky, who's a Boston Terrier, any instance of check with regard to dog, mammal, and animal will also be true, or will resolve as true. Bitwise and bit-shift operators. This will be the last technical slide before we go into the programming example. Okay, here we have all the different operators to deal with binary manipulation or bits manipulation. These are seldom used unless you are doing a lot of very low level manipulations of bits. So I'll just let you read through it. If you need, you can always refer online or with Java documentation. Welcome to the beginnings of our Pig Latin translator. The first method we will be looking at is vowel method, where we will take in a character C and check whether it's a vowel. The first thing we'll do is to make sure it's all lowercase so that we don't need to deal with all the permutations. And then we can use the equal operator that we just looked at to do the checking. And we'll always return true, except if it gets to the bottom, and we'll return false. Now let's look at how we test our code. Here are some of the test cases, and the positive and the negative for characters, and let's run it. Let's check if the JUnit can find any bug with our code. Takes a little while to set up, and it will go through all the different test cases, and it's green. Let's look at convert word next. This is the method where we will convert one word at a time into Pig Latin. First thing to do, let's break the word into character array so we can deal with it one at a time. And let's take care of the easiest case first. If it's a vowel, we just return with a WAY added to it. Then the next part is to look for the remaining parts after the consonants. We will look through a character at a time and using all the operators that we have learned to check if it is a vowel or a Y character. If there's no remaining, it's easy. We just return it with AY appended to it. Then we have the rest of the word. Let's lowercase all of them just to keep it consistent. And then we'll declare a new first character, which is now the start of the remaining. And we make sure that we obey the original casing. If it's uppercase originally, it'll be uppercase. Then we compose the word together again. Time to check if our method worked. Let's add some test cases, add the simpler ones, add some edge cases. In this case, we have more. Let's add a few more, and then let's run it and check. Wow, it passed. Sometimes it's good to double check that our test is working by putting in a negative case. Let's run it. It should fail now, and it does. That's good. Then we can just take that away and make sure it runs again. Perfect.